Our next speaker is Dave Copeland. He is from Washington, D.C. He works for O-Power, and he's a huge nerd for the command line. And that's what he's going to be talking about today. So you can learn how to test drive your command line applications in Ruby. Thank you, Dave.
Thanks. Hi. Morning, everybody. So we have the slides going here. So I'm going to talk about how to write command line applications in Ruby using test-driven development. Okay, so briefly, who am I? Dave Copeland, obviously, got that. So I'm a principal engineer at O-Power, and the reason that's relevant is, so we're an energy efficiency software as a service company in DC. We have an office here. When I started at O-Power, it was a very small startup, and so as I'm sure those of you who've worked at a startup or a small company know, when you're a developer there and you're working on the product, you often have to kind of do whatever it takes to get something done so you can get back to working. You don't have specialists to take care of everything. And getting that done often requires writing a command line application to script something or automate something or glue two things together. And they're written in haste. And myself, having written many at O-Power and other places that I've worked, I wish that I had tests for those applications because my name's on them. And 6 months later, when I have to fix some problem, I have no tests and no way to actually figure out if it's working or not. And it's a pain. So it turns out it's actually not that hard to use TDD with command line development if you know a few simple tools and techniques that we will talk about. So if you are one of the 2% of people in the software development universe that doesn't know what test-driven development is, here's a very fast overview. You write a test to assert that your code does something that it currently does not do. And then you run that test and you watch it fail. And then you fix that test by making your code do that thing that it is supposed to do. And you run the test and you see that it passes. And you do that as simply and quickly as possible, focusing only on getting that done. And then the important third part, which many times we forget, is to fix up all the hacks that you did to get the test to pass, called refactoring. So, test, fix, refactor. You just do this constantly until your app is done or you have to go home or whatever. Okay, so the challenges in particular for command line interfaces all boil down to the fact that we tend to write our command line apps on production, right? Not like your production server, but you write it on the machine where you're going to run it. So if I'm writing a command line app that's going to manipulate system files or delete files or modify things in my home directory, I can't just run tests on my machine because it's going to screw up my home directory and screw up my system. So I have to take extra care not to do that. Now, you could certainly buy a series of servers on which to develop your command line apps and go from dev to QA to stage to production. Like, that's kind of crazy, though, for such small, simple things. So we'll see how to deal with that. And it's actually pretty easy. So we'll do this by going through a demo app that I'll build. And I promise I won't make you watch too much of me typing. But basically, we'll have an app to maintain our dot files, right? So we've got our bash RC or our input RC or vim RC, and we want to, we've got those in a Git repo somewhere because we like to keep track of things, and then we want to set up a new environment or a new machine or something like that. So we want to do this really easily and simply. So we'll make a quick command line app that does that. So let's get to it. Now, we talked about the test, fix, refactor cycle. But I think it's really important that there's like a step 0, which is bootstrapping your environment. And I think what I always had a problem with was to start up running tests on some command line app, I've got to go find where I did this and figure out where these files go and set up all this stuff. And like with Rails, for example, you just type Rails foobar, and then you have an app, and all the infrastructure is already there to run tests. So we need that for the command line. So I created a really simple gem called Methadone that does that, but you can create one that's just like however you want to do it. But the point is to be able to go from like 0 to running tests in like 2 seconds. Right, it reduces friction and it makes it really easy. So let's see that. So like I said, I have this thing called Methadone. It basically makes this gemified project for you. And it's more sophisticated than what you get with bundled gem. It actually sets up a rake file with running tests, and it's opinionated to the way I want to do it. So I'm not saying like you have to use my thing, but something that does it however you want to do it. And so when we bundle install, we'll see like a whole bunch of stuff. Hopefully that's readable. And all that stuff is coming from Aruba right there, which is a series of Cucumber steps tailor-made for command line application testing. And if you don't know what Cucumber is, it's a way to write tests in English and use that to drive your TDD cycle. And we'll see some of that too. It's actually really easy if you haven't heard of it, which would be strange, but whatever. Okay, so let's see what it actually gave us here, just to prove that this all works. Right, so we've got a little executable that just, does nothing. We can run one unit test, so we have a place where we can put all of our tests already, and we can run one feature, and so we have a place to put our feature. So any test we want to do in 2 seconds, we have that ready to go, and I think that's important to getting started. Right. Okay, so let's add a feature, right? So this is Cucumber, and so I've just written down in plain but magical English what we want our app to do, right? So if you're not familiar, everything below this scenario is actually going to be executed by Cucumber, and we'll see how that works. So given my dot files are in some Git repo, when I successfully run full stop, which is English for period or dot, which I thought was clever, and I give it my Git repo, then I expect them to have been checked out in tilde/dot files and symlinked in tilde. Okay, right? That's exactly what we want this sort of app to do, right? So this is kind of a problem, though, because this is all my home directory. So if I were to run some tests on this, if I were to run that, it's going to just destroy what is in my actual bash RC in my actual home directory. Now, I could certainly set up my Git repo of test dot files to be my actual dot files. But then if you try to run it, then you're going to get my dot files. And my dot files are pretty awesome, but you probably want to keep yours. So we're going to have to sort out something else. Right, because remember, we're developing on production. So what we want to do is take a step back and not make the first round of tests like so fancy, right? So we're fancy because we're defaulting where things are getting checked out and symlinked to our home directory. So let's leave that feature for later and just get something going where the user has to actually tell us where they want things checked out and set up, so we can sort out how the checkout, symlink, all that stuff is going to work. So here's the revised scenario, and it's pretty much the same except that we are requiring a second argument. That's slightly cut off. A second argument to our app that will tell it where we want things set up. And we're giving it /temp where we can mess around and no one cares. So we've typed that in, and because of all of our awesome setup, we can just do little rake features and see that this, in fact, fails. Okay, not quite, right? So this is Cucumber telling us I don't know how to execute all those steps that you just wanted me to do. So let's implement those steps. Okay, so the first one is we've got this empty directory. So all we're going to do is just kill it and make sure it's clean. That's pretty easy. Probably don't want to pass this like something other than temp, but whatever. Given I have my dot files in a Git repo, well, for the purposes of this demo, I just set up a repo that has everything I need in it. But if you wanted to be really stern, you could actually set up your repo in here so that it could be really bulletproof. But anyway, I have it set up, so that's kind of a no-op. So checking that the files got checked out. So I know in my special Git repo that I set up, I've got a bash RC, a vim RC, and an input RC. So I'm just going to check that those are there. And so we can see here that I'm calling some other step called a file named something should exist. So this is from Aruba. Aruba gives us a bunch of stuff like this, and so I don't have to worry about how to check for that. Aruba can handle that for me. Checking for the symlinks, I'm doing a little quick hacky thing and doing the same thing, essentially. If you want to get fancy, you could stat these and make sure that they're actual symlinks, but again, purposes of a quick demonstration, this should suffice. So we've implemented our steps, and we're still on our quest for a failing test. So yes, okay, we got some red in there, and then my dot file should be checked out in temp dot files. Can't find the file .bash rc. Right? Not surprising because we haven't written any code. So cool, now we've got something to do. And now we don't want to implement the entire app right now. Right? We have one thing that fails, so we just want to fix that one thing and see if we can get through that. So here's what Methadone generated, just a basic app that just says option parser setup. So to get just this one test passing, we're going to use file utils, which if you don't know what it is, it's a module that gives you a bunch of methods that look like Unix commands, which you can see we're using down there. So we get this kind of shell scripty way of doing stuff, but we're still in Ruby, which is awesome. So we yank stuff off the command line, make our checkout directory, change to it, and then run git clone. And hopefully we have gotten a little bit farther in our quest. Yes, all right, we got one extra line of green, which is awesome, and now we have a problem that the files aren't symlinked to where they're supposed to be. Again, not surprising because we didn't do that. We're doing it, one step at a time. Okay, so here's where we left off. This is the bottom of the file we were just looking at. So all we're going to do is for every single thing in our .files directory that we checked out, we're going to symlink it to the current directory, which is where we want things checked out. So we have this horrible expression to get everything, and then we're making sure that dot and dot dot don't get symlinked, or we get a rupture in a space-time continuum or something. So let's see, did that now give us what we want? Okay. Beautiful. It's all green. Our app totally does the one thing that we have decided we wanted it to do. That is great. So that's our 2 steps, right? So step 3 is refactor. Now, you might not refactor after the first time, but for the purposes of demonstration and so you can see the level of OCD that I have about this, we'll refactor this. So the problem is I want to open up this app and see the main logic at the top. Instead, I'm seeing a bunch of option parser crap that I don't generally care about. Further, I hate that dir regex thing. I don't want it there. I want a method that explains what that is so I don't have to look at it. So let's do that. So we'll yank out the main logic into a main method that we'll put at the very top of the file. And you can see I've killed this dir thing with a method called .filesIn. So now our main method just reads exactly like what the app does. When I open it up, I can see exactly that. I don't have to be burdened by decoding some regex or whatever. And then here's the method we extracted to handle the dir expression and checking for dot and dot dot and all that stuff. And then at the very end, we just call main. So cool. That looks good, right? But did we break anything? So that's what the tests are here to tell us. And just so you know that this is not totally faked, right, here's said code. And great, still green, right? So that means that my change was totally okay and I didn't break anything that I have asserted that my app does. So perfect. And my OCD has been satisfied to have a nice application that I like to look at. Now, we've done all that, but we still want the home directory to be the default, right? Aren't we still in the same place that we were before? So, right, we're on production. Again, we don't want to screw up my home directory files. We don't want to screw up yours when you run the tests. So instead of using tilde in our scenario, we're going to use the English phrase in my home directory. And so this will not only read better, but it will make it a little easier for us to test. And it's totally okay to do that because we want our apps to be testable. So here's the scenario. And so it looks kind of like the first one that we saw, except instead of having those tildes everywhere, we're just using the phrase in my home directory. So it's very clear about what it's doing, and we're not hard coding any actual paths. So how do these look? So all these are just kind of lightweight proxies to the steps that we implemented the last time. And you'll notice instead of using tilde, we're using env home, which is the environment variable home, which is a standard way of getting the user's home directory. And I think it actually works on Windows too, so that's double good. Right. So, and then what we do is in our setup, we can specify code that happens before or after a scenario runs. So we're going to fake out home. We're going to change where the home environment variable is, because when Aruba runs our app via Cucumber, it inherits the environment that we've set up. So we can futz with the environment, do what we want. So again, we're going to clear out a fake home directory, and then we're going to say, okay, the environment variable home is now equal to this new fake location. So let's see. Again, we don't want to do anything until we see something fail. Okay, so now you've got this giant ugly stack trace, and we've got some sort of nil. So let's check it out here. Right, where is it in our thing? Line 9. Okay, so line 9, make dir p is getting nil, which apparently it doesn't like because our argv only has one thing in it. So the second element is nil. Exactly makes sense because we're not giving a second argument. So let's just fix that. Equals, right? So instead of using tilde, which would make this work, we're going to use env home, which will make it work and be testable. Dir.nil. And let's see if that worked. Yes, all that green, lovely. So now we know that the logic of defaulting to the home directory works, and we can verify it in a way that doesn't screw up our home directory. So, okay, right, we just saw that. Okay, right, I have all these slides just in case the terminal didn't work, so forgive me. Okay, so we've seen that we can add new features using this. So we could continue and think of all kinds of new crazy features. But the UI actually really sucks right now. So, right, we're lucky to get -- help because we're using option parser. But, right, so we document that we take options, which we don't. And we document that we don't accept or require any arguments, which we actually do. We have one required and one optional one. So that's a problem, because we want our apps to be polished, not just functional. And you probably noticed there's not a lot of if statements in my code, so if anything went wrong, who knows what's going to happen. The user's probably going to get some horrible stack trace that doesn't explain the problem. So we need to fix that too. So let's fix the UI first because it's you want to test that through Cucumber. We're still in that kind of mode of using Cucumber. So here's a scenario which describes a non-sucky UI. So our name is full stop. When we run -- help, we should get a banner, and that banner is that usage : full stop blah blah blah, and that banner should indicate there are no options, and it should document the arguments. .files repos required. Check out there's not. This table right there will be given to us in a nice data structure. And then we also want a one-line summary so that in 6 months, when I forget my little clever name, I will know what full stop does by getting help. So, okay, right. So, all of this is the standard out or standard error of the app, and Aruba gives us a lot of different steps, sort of like this, that we can use to make assertions about the output, which is awesome because we don't want to have to capture standard error and standard out and do all that manipulation. Aruba has handled that for us. So here's how we implement those steps. We've got to save the name of the app so that we can then assert in the second step that it shows up in the banner. And then, if we want to indicate there's no options, we make sure that that square bracket options is not in the output. For checking the documentation of the arguments, we're going to build up a string that represents what we want to see on the in the help. And so that string would be .files repo space square bracket checkout dir, because square brackets means optional. So we'll just build up the string with some awesome Ruby mapping and then make sure that the output has that string. And then, so for checking for the one-line summary, obviously I don't want to install a grammar checker and check for active voice in my description. I mean, that's just overkill. We'll just make sure that there's a space between the banner and the description, and that the description has like a couple of words in it. That should be good enough for now. Okay, so we've got all that. Let's see what that does for us. Okay, so we've got some red. Okay, so we've got actually a little farther, right? We do have a banner because option parser gives it to us. So that's cool. Unfortunately, our banner has options in it, which it should not. Right. So rather than kind of step you through fixing these one at a time, we'll just sort of like skip that a little quickly. So this is what we have now. To solve the problem at hand, we would do this. Then we will get another failure, which is solved by doing this. And then we'll get another failure, which is solved by doing this. And fast forwarding all of that, let us see if that is done. All right, look at all that green, and now we have a pretty nice user interface. Documents everything, explains what it does. Awesome. Okay, so all kinds of happy paths have been made happy. But remember, I was saying before, like we've got makedir and all these things that could screw up. So we need to deal with the unhappy path. And right, so here's our main method again. Like any of these things could go wrong, and A, we're not dealing with them, and B, we don't even know what we want to do. So we could do more hackery with the environment, right? We could send all kinds of stuff in and have if statements everywhere to simulate everything. That's going to make some pretty horrible code. And while we want to design for testability, this is a little extreme. So the Cucumber tests are great for this happy path stuff and interacting with the user and all that, but it becomes a lot more difficult to simulate all kinds of esoteric edge cases that you want to make sure are handled. So unit tests will help us do that. They'll also require us to get some testable units, right? Now we have a big procedural blob. We have nothing we can test, and we want units, right? We want little bits of code that just do little tiny one thing so we can test them. Unit tests are going to be faster to run. They don't require as much setup. So let's go with that. So first thing we have to do is refactor, and we can do that because we have all of our awesome tests. So here's our main method and our extracted .files in. So we're just going to yank those out of the executable and put them into a module. And then we can include that module in our tests and do stuff with it without having to actually run the application. So here's our executable where we've yanked all that stuff out. We throw it back in by including the module. So hopefully that was a good refactor and we're good to go. Only one way to find out is to run those. Yes, everything passed. And just to prove that I am not making this up, all right, there's everything in our lib directory. OK, cool. So now let's start with makedir. That's the first thing that happens. What happens if that fails? So the documentation doesn't help us, right? It actually throws an exception if things go wrong. Those exceptions aren't documented anywhere. Experimentally, the message of those exceptions are horrible error no things with no access and things that we don't want to tell the user about. So we want to catch those and give the user a better explanation as to what we were trying to do when things went wrong. So we could use some mock file system stuff like mockfs or fakeFS. Those actually aren't really up to this particular task. They require a lot setup and require some changes to our code. and get into that later. We can certainly make up our own in temp, which we've been doing. But again, this is too much setup for a unit test. And honestly, all this /temp stuff certainly isn't going to work on Windows. So we need something that doesn't require all of this like environment setup. So we'll mock out the code, right? We're including file utils, so we can mock those methods to do whatever we want them to do. So here's a test. We're going to use Mocha. There's 1,000 other mocking things if you don't like that. I'm making a class to include our CLI modules so I can mock out makedir, which we can see right there, and it's going to throw a runtime exception. That should be pretty reasonable to test a failure. Then we're going to call main, and we're going to assert that it raises a runtime exception, which is not surprising since we just made it do that. But what's really important is this last part here. We're going to check that the error message of the exception is something useful and actionable by the user. So there was a problem creating this directory. And we might assert more info than that. But for this I think that's good. So now let's do rake test. Okay, we got a giant stack trace, test failure. Good. Okay, so now we can get something done here. Okay, so this is our main method. And remember, we're not going to make the ultimate end-all, be-all, exception handling file utils thing right now. We're just going to fix this one problem in the quickest and unfortunately cheesiest way possible, which is to just do rapid begin rescue and raise that problem, right? So it works, I hope. Oops. Okay, it works. I'm sorry there's no green. If there's a way to get green for unit tests, I would love to know about it. I love that green. Okay, so we fast forward, right? Let's say we wrote tests for everything else and made them pass in the simplest way possible. We have this horrible begin. This is terrible, right? I mean, it works, and the user has a good experience, but the code is terrible. Just to prove that I did, in fact, do that, we will do this again. Okay, so right, 4 tests. They all pass. We're good to go. So we got to fix this. So let's refactor this. So what we'll do is we'll stop including file utils, and instead we'll use method missing to proxy our file utils-like calls to file utils, and we will wrap that in a begin rescue so that if anything goes wrong in file utils, we'll catch it, return true or false, which we'll see why in a second. So this, obviously, we lose the ability to get the return value of the file utils calls, but we don't care, right? We're not using the return value. We might never need the return value, so let's just make something that works for what we have now and worry about things later. So now the code, and especially if we had a wider monitor, it would look a lot better than this, but we can see that we still have our shell scripty-like stuff along here, but then we can just say, or raise some problem. So now the code kind of looks like it did before. It's just got a little bit more error handling in it. And since we have our awesome bevy of test suites, we can make sure that that did not screw anything up. Sure did not. And, let's not forget our features here. We haven't seen them in a while. Yes, all green. So we totally did that. Our code is good and still readable. Not too bad. Okay, so we're getting close to the end. So let's skip this here. Okay, so in summary, what do we learn? What do you need to take away from this? Start with a template. Like I showed you Methadone, it just creates everything. Just come up with a template for whatever you want your command line apps to do and set up all the testing stuff. Make it as easy as possible to start writing tests for your command line app. Make it just like it is starting a Rails app. Second, work outside in. I know there's some debate about that, but I think a command line interface, you're typing something on the command line, it's very natural and easy to start with the interface itself and using Cucumber and Aruba to start that. And it's really good for the happy path stuff and anything that interacts with the system. But you're going to have to get to unit tests if you want to test crazy edge cases or simulate things that might be very hard to simulate in the real environment of Cucumber. And again, design for testability. It's totally okay to do things that make your code easier to test because that makes your code easier to test. So that's all I've got. Thank you. Anyone's got any questions? I think we might have a couple of minutes.